Hope everybody's well and feeling good. Wow, we've got everybody here tonight. Nicole, Daneo, Lamique, Refumoditswe, Samara, Leander, welcome. Nice to see all of you and have you here with us again. I hope I said hello to everybody. Sayuri, did I say hello to you? Sake, hope I said hello to you as well. Yeah, not long to go now. Hey, Matrix, you've got one day and you start on Wednesday, English paper 1. So hope everybody's okay and feeling ready. So yeah, we'll get you ready for maths. We're almost there. We're going to finish off this Euclidean geometry course this week. And then we're also going to do another course on, you start with physics tomorrow. Okay, Hamid. Oh, sorry, I didn't realize that there was physics tomorrow. I thought English was the first one. Okay. Wow, what an introduction to matric finals, hey, starting with physics. Well, I wish you all of the very best. And if there's anybody else that's writing tomorrow, all the very best to you too. Okay. All right, well, let's get cracking. Again, as always, I am here for you. If there's anything that I do or say that doesn't make sense, or you want to ask a question, or you want me to slow down or speed up or explain something again, just let me know. I'm more than happy to do any of those things. So what you see on the screen now, the do now, does it look familiar, Karabo? This was emailed to Watobe by Karabo, and she wanted to know how would we answer the following question. So I thought that this would be the perfect do now. So it's basically a lead on from what we were doing last week. So if we look at the first picture, if we look at 2A in the diagram below, excuse me, they want us to prove that AB over AD equals BC over BF. But again, I want you to ask yourselves before you get started, how many triangles can you work in? Remember, you can see 2 pairs of parallel lines. So there's 2 different triangles that you can work in. All right. So in this case, we can work in triangle ABC because DE is parallel to BC. I'm sure everybody sees that. And then matrix, we can also work in triangle CAB, which is really the same thing. But can you see here, you've got EF parallel to AB. So it really is the same triangle. You're just looking at it from 2 different perspectives. So now let's make something. So what we see here on the left-hand side, this AB over AD, that's a guide, right? It's telling us to start with this. We want to look at that and try and make a proportion out of that, right? So I'm just going to scroll down and, oopsie, let me just make it bigger again. And I'm going to write, get my pen back. I'm going to write AB over AD, and I would like Benedict. Can you finish my proportion off for me and give me a reason and the parallel lines? So Benedict says AC over EC. Okay, so Benedict, if we went AB, the whole thing, over AD, we must go AC. I agree with the AC part, but I don't agree with your EC. So AB on this side over AD, so the long side over that side. So on this side, Benedict, we've got to do the same thing. Okay, so it's got to be the long side, whoopsie, over, that's it. Okay, good, Isaiah, it has to be over AE. So I'm sorry I'm writing in different color. Oh, I don't even know, is that visible? Can you see the yellow? Thumbs up, thumbs down. Let's maybe go back to blue. All right, now, what's our reason? What's our reason, Matrix? So Benedict has given us the lines, Isaiah has given us AE. What's the reason? Why are we allowed to make this statement? What is the reason? There we go. Thank you, Hamed. Okay, so proportionality intercept theorem. All right, what's missing? What do I still need to write here, Matrix? I'm not going to get the mark for the reason if I don't write the parallel lines. Quite right. Good, Benedict. Yes, Hamad. Yes, Karabo, the parallel lines. Okay, so Karabo, which parallel lines are we talking about in this case? What parallel to what in this case, Karabo?
I chose A. Yes.
Do you agree with Isaiah?
Yes, ma'am.
I do as well. Okay, well done, Karabo. Well done, Isaiah. So DE parallel to BC or BF, 100%. Okay, nice. Now that we've worked in one triangle and we've got something about AB and AD, let's have a look at the other proportion that they gave us, right? So let's do this in pink. So here they gave us BC over BF. So that's BC over BF. Let's see if we can make a statement about that. All right, so BC over BF is equal to what?
BC over DF. It equals AB over AD.
So what you're doing is that you're looking at the triangle from a different perspective. This line over here, line AB, is parallel to line EF. So if we've gone BC over BF, on this side we have to go AC over AE. Can you see that, Matrix? Okay, so if I've gone BC over BF, here I must go BC over AE. Sorry, AC over AE. Beg your pardon, I said the wrong letter. Okay, so again, BC over BF is equal to AC over AE. All right, because here are the parallel lines. Again, my reason, proportionality, intercept theorem. I have to name the parallel lines. So in this case, the parallel lines are what, Jaden? What parallel to what?
AB parallel to EF.
Perfect. Well done, Jaden. Thank you so much. All right. So as he says, AB parallel to EF. Beautiful. Well done. All right. And you said the same thing, Karabo. Good. Lovely. So what do you notice, Matrix? Looking at both of your proportions, what do you see? What do we notice about both of them? Anyone can tell me. What do you see?
They both equal to AC over AE.
Exactly a C pair. Okay, right, Isaiah. So they're both equal to AC over AE. So then they must be equal to one another. So therefore, AB over AD equals BC over BF. And I think if we just go back and check, AB over AD equals BC over BF. There we go. We've answered the question. Okay, is everybody happy with that? Thumbs up, thumbs down. How does it feel? Are there any questions? Okay, I need it. Thanks to Zayo. Cool, Rekomedetswe. Well done, Karabo. Okay, Melukuhle, it's great. Good, I'm glad to hear that, Melukuhle. Sayuri happy, lovely. That makes me happy, Sayuri. Cool, the CP, thank you. Thanks, Loyanda. Cool, Sake, thank you. All right, guys. So the next question is exactly the same, but different. It's really, really exactly the same sort of question. So you've got to identify which two triangles you can work in, and then start with the left-hand side, write what it's equal to, go to the right-hand side, write what it's equal to. You'll see that they're equal to the same thing, and then you can conclude that they're equal to one another. All right, so we can do it quickly if you want. Shem, I know, Karabo, these are the questions that you asked. So yes, let's just do it quickly, and then we can move on and we can start talking about similarity, which is today's lesson. All right, so now I'm going to ask you, in which two triangles can you work? All right, and let me see. Oh, Luyanda, I'm going to pick on you for this. Okay, so name one of the triangles in which we can work, Luyanda.
PQR.
PQR. Luyanda, you are 100% correct. Okay, so Luyanda says triangle PQR. All right, and he's quite right because PQR is here. And you can see that we've got ST parallel to the third side. Okay, so yes, Luyanda, 100%. All right, Sake, I'm going to ask you, what is the other triangle in the diagram that we can work on?
Ma'am, is a triangle WQR.
Is a triangle WQR. Well done. Excellent. Well done. Very nice. There we go. Triangle WQR. Good. Okay, you guys are on fire tonight. This is brilliant. So now we need to make a statement about PS and SQ. So I'm going to write PS over SQ. And I'm going to ask, hold on a second. I'm going to ask Sayuri, can you please tell me what PS over SQ is equal to and why? Ooh. Okay, so Hamid says PW over WR. I don't agree, Hamid. I don't agree. Unfortunately, I'm sorry. Good attempt, but I don't agree. So now, without coloring in this triangle, is it?
Isn't it QR over TR?
You're much closer. So in this case, it would be RT over TQ.
Oh, RT.
Okay, can everybody see that? It would be RT over TQ. Well done, Karen. Okay, so let me just rub this out just to make it obvious to everybody again. Okay, we're working in the red triangle identified for us by Luyanda. All right, that's this triangle here. All right, so I'm going to try to draw it as nicely as I can. Okay, and then there, the other side, and then here is the third side of the triangle. And then line ST is parallel to, PR. Okay, so we went PS over SQ, so that's got to be equal to RT over TQ. Reason?
Crop-intercept theorem, PR is parallel to ST.
Thank you, Luyanda. Good. Okay, and now we finished working in the red triangle. Now we got to go and look at the pink triangle. So I'm going to get rid of the red, because otherwise it's a bit much. And now let's go and look at the pink triangle. So there's the third side, there's that side, here's this side, and of course, this line here is parallel to that one over there. So now let's go and see what we can say about RU over WU. RU over WU. RU over WU is equal to what over what?
RT over TQ.
Exactly. RT over Q. RT over TQ. Yes, Carabo. Okay. And again, matrix, it would be the same reason. Proportionality, intercept theorem, only now the parallel lines are UT parallel to WQ. And again, we're going to go and look at, let me just move this up. What are they both equal to? Okay, so PS over SQ and RU over WU equal the same thing. They both equal RT over TQ. So therefore, the deduction is that they are equal to one another. All right, so then it is proved. Okay, so therefore, PS over SQ, can you see how it's exactly the same, just different letters, is equal to RU over WU. Okay, so thank you, Carabo, for sending those questions. I think that was a nice way for us to be able to get into today's lesson. Any questions before we move on? Or is everybody happy?
Ma'am, can I ask? So
Please.
you see putting in your final statement, right? Like when you
Yes.
say therefore, does
Yes.
that not need a reason for it, or is that enough already?
No, it's a deduction that is made on something that we've already stated. So I don't need to provide a reason down here as well. All right. So because this comes as a result of this. So in other words, if let's say I had something like this, Luyanda, I mean, I don't have a diagram in front of me, but let's say I had angle A1 equals X because they're corresponding angles because AB is parallel to CD. Then let's say somewhere else, I've got angle D is equal to angle X because of tan chord theorem. So now the deduction, all right, is therefore angle A1 must be equal to angle D. Does it make sense? That's the context in which we're working. So this is where our proportion is and our reason and our proportion and our reason, and then there's our deduction. Okay, it's a pleasure, Caraba, anytime. All right, so the last one here doesn't need a reason because we have shown, unless of course, if you wanted to write a reason, the reason would be because they both equal X, but that's not necessary. Okay, does that answer your question, Carabo? Sorry, Luyanda?
Yes, thank you, ma'am.
Okay, it's a pleasure. Okie doke, so let's move on and start talking about similarity and similar triangles. So before we start talking about similar triangles, this is what I always take my matrix through, and we're going to be talking about corresponding sides. So when we talk about sides that are corresponding in triangles, it means that they are the sides that are opposite angles of the same size. So here we have two triangles, ABC and PQR. Let me just make them a little bit bigger. And opposite angle A, which is 47, is side BC. And opposite angle R, which is also 47, is side PQ. So we would say, talking about these two triangles, that sides BC and PQ are corresponding. Okay, that's what the word corresponding means. Okay, so they're opposite angles of the same size. Now, specifically, when we talk about triangles being similar, okay, it means they will be similar if they are equiangular. What does the word equiangular mean? What does equiangular mean?
All angles are equal.
All angles are equal. Okay, so all three, exactly, Hamed. Thank you, Luyanda. All three interior angles are the same size. Not necessarily 60, but they're all three of them are the same size, all right? Or the sides are in proportion. What does that mean? What does it mean if the sides are in proportion? Not necessarily that they're equal, Daneo. They're in proportion. Okay, so remember we've been talking about proportions. So they're in the same ratio, exactly. So maybe they're in the ratio 1/2 is the same as 3/6. They're not necessarily equal, but they are proportional to one another. Or maybe they are 1/2 is 5/10. Or maybe we've got something like 9/18 is 25/50. So not necessarily the same, but proportional to one another. All right, so remember we've been working with proportions now. A proportion is a statement involving two fractions, all right, and when we simplify them, they have the same basic value. Okay, so either the one or the other. So we can prove that triangles are similar by proving that they're equiangular, or we can prove that triangles are similar by proving that their sides are in proportion. And this second one that I've highlighted in red here, I know my boys always seem to get this one wrong. It's actually very, very easy. And a lot of matrics, for some reason, just, I don't know, they just kind of forget about it, or they get confused, or whatever it is. But it's actually very, very simple. It's one of the things that we will talk about. All right. So now, when you are asked to prove that triangles are similar matrics, you only have to meet one of the conditions. So either you're going to prove angle, 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 or you're going to prove sides in proportion. You're not proving both. Okay. And again, this is just showing you how the two work together. So if two triangles are equiangular, they are similar, so their corresponding sides will be in proportion. So that means the sides opposite, the angles of the same size. Or two triangles have sides in proportion, they will be similar, and the angles are equiangular. Does that make sense to everybody? I know I've gone through it quite quickly, but I'm sure your teachers explained this to you at school. Is everybody okay? Thumbs up, making sense? Any questions at this point? Cool, thanks, Saki. Thanks, Karabo. Simple enough to comprehend. Well, that's exactly what it should be, hey? Because if you don't understand something, if you can't explain it simply enough, you obviously don't understand it very well. That's just what Albert Einstein said. Okay, cool, I'm glad. All right, so any questions? You know who to ask. All right, let's have a look at what I've put up here for you. Okay. So, when you are stating that two triangles are similar, all right, you name the shapes according to the corresponding equal angles. Now, we're not talking about corresponding angles like the ones that we have with parallel lines. We're talking about corresponding angles, meaning the ones that are the same size. So if we have a look at the diagram, all right, so I know it says above example, but I've stuck it next to it, all right, the corresponding angles are as follows. Angle P over here, let's use different colors. Angle P over here corresponds with angle B. They are the same size. All right. Angle R corresponds with angle A. All right. Next one, let's choose a different color. Let's go with purple. Okay. Angle Q corresponds with angle C. All right. So if we were to state that these two triangles are similar, we have to put the letters or the corresponding angles in the same order. So if we are talking about, let's just pull this over. If we are talking about triangle PQR, you would have to say triangle PQR corresponds with triangle BCA. All right, so you have to do it like that. That's not optional. It has to be done like that. So the corresponding angles have to match up. All right, so now identify the corresponding sides. So let's go back and pick on someone who's been Chad. Let's pick on you. Okay, side PQ corresponds with side. Which side, Chad? Indeed, well done. Smashing it. Okay, with side BC, excellent. Okay, let's ask some. Who am I going to ask? Karen, side QR corresponds with side? CA, good job. Okay, nice matrix. Well done. Thank you, Karen. All right, and hang on a second. I know who I want to ask. Samara, I'm going to ask you. Samara, side PR corresponds with? Okay, thanks, Ahmed. That's fine. With? BA. All right. So I don't know if I'm already telling you stuff that you know, but I just wanted to be thorough with the way in which we name sides and the way in which we name angles, and that they do have to correspond with one another. Okay, so there would be 6 different ways in which we would be able to do that. If we said that triangle PQR is similar to triangle BCA, if I wanted this, that also means, let me just say this before I carry on, that also means, can you see that side PQ here, side PQ goes with side BC. Let me just move that down. Did you see that? Side PQ up here goes with side BC. Then when we do the last 2, so in other words, QR over here, that went with CA. Do you see that up at the top? Over here, it went with CA. And then when we went first and last, so PR, that went with BA. That's exactly what you guys told me. And that's what we wrote over there. Okay, so the sides have to correspond and the angles have to correspond when you are working with similar triangles. And when they give you similar triangles, they actually tell you them, then you may assume that the sides correspond and that the angles correspond. All right, so if they say to us, and I'm just making up something else here. So if they say to us triangle PQR is similar to triangle XYZ, all right, they tell you that, you can assume that angle P corresponds with angle X. Indeed. Good, Chad. And angle Q corresponds with angle Y. Y, correct, Silindile. Y, okay. And angle R corresponds with angle Z. Okay, matrix. And on the same vein, that means that side PQ in the one triangle corresponds with side
XY.
XY. Excellent. Okay, let's use a different color. Okay, let's use blue. And QR corresponds with
YZ.
YZ. Good. You guys are smashing it again. All right. And side PR corresponds with side
XZ.
Excellent, Saki. Thank you very much. Thank you, Melokule. Perfect. Okay, so if they give it to you that way, then it's much easier, but that is the assumption that you are allowed to make. Okay, so now that we understand about the order, we understand what corresponding sides are, we understand what corresponding angles are, let's get into the questions. All right, so the proof is tested. So you will need to learn that. But that's not something I'm going to focus on in this particular lesson. But if you do want me to go through proofs at some stage, then we can certainly do that. All right. So here in triangle ABC and PQR, again, we know that A corresponds with P, B corresponds with Q, C corresponds with R. So if triangle ABC is similar to triangle PQR because they are equiangular, it means that the corresponding sides are in proportion. So in other words, can you see how they've gone AB, the first two, over PQ, the first two, equals BC, the second two, over QR, the second two, over first and last AC, over first and last PR. And of course, any two of the three makes a proportion. Okay, so again, if we're looking at that, that's a proportion, isn't it? If we look at these two, that's a proportion. Or we could compare those two together. All right, so there are three different proportions that we can make. All right, I just want to check, is everybody happy? Is this making sense? Am I going too fast? Are we all right? How are you feeling right now? Cool, Hamad, cool, Samara. Thanks, Chad. Thanks, Samara. Thanks, Sake. Okay, I am muted. Good. Okay, Luyanda. Good. Okay, I'm glad to hear it. Cool, Swelith there. Nice. Cool, Isaiah. Now, something very important, and I know that when I teach this, I say to my matric boys, I've always stressed this, and then I had one of them come and nag me for marks after they'd marked trials, and I said to him, I can't give them to you because you've gone exactly against what we've said here. Okay, so now your teachers would have taught you this, I'm sure. When you are proving that triangles are similar, so in other words, we want to prove triangle DEF and triangle RST similar to one another. If we are able to prove that D equals R and E equals S, what are we allowed to conclude about F and T? So it says F and T are equal, exactly, because if you have shown that two angles in one triangle are equal to two angles in another triangle, then the remaining angles will also be equal. But you can only use this reason You can only say remaining angles of a triangle as your third reason. You cannot go D equals R vertically opposite and E equals S remaining angles of a triangle, and then F equals T angles in the same segment. You cannot do that. They will mark that wrong. Yes, and it's because the interior angles of a triangle add up to 180 degrees. So you can either write, if you want to, as a reason, you either write remaining angles of triangle, or you can write angle sum in triangle, or interior angles, what is it? Interior angles, some interior angles of triangle. There are many different ways in which you can write that. As far as I'm concerned, I just kind of tend to stick with the same thing. I always go with this, angle sum and triangle, but that's just me. But if you want to use one of the others, that's absolutely fine. The DBE does approve all three of those. Okay, so remember, very, very important, you can only say remaining angles of triangle as your third and final reason when proving similarity. If you say it first or second, you are not going to get the marks. Even if you're right, even if you're correct, you won't get the marks. Yes, Rekomodetswe, go for it.
Ma'am, I wanted to ask you if another reason you can say third angles of a triangle.
Yes, absolutely. Absolutely, you can. Nothing wrong with that. Perfect. Okay, so, but it has to go third. All right, so this is just a little sort of explanation for you. It's obviously very simple. You guys understand this. So we've got triangle DEF. When we add D, E, and F together, we're obviously going to get 180. So if we make F the subject to the formula, F is going to be equal to 180 minus the sum of D and E. So in triangle RST, that's also going to add up to 180 degrees. So angle T is also going to be equal to 1 minus the sum of R and S. But we know that D, E, and RS equal one another. Okay, because they told us that D is equal to R and D is equal to S. So therefore, that's why F and T will be equal to one another. And then this is when you can write any one of the four things that we've discussed. Okay, either remaining angles of a triangle, sum of angles of a triangle, interior angles of a triangle, or whatever the case is. All right, matrix. Now, let's go on. All right, so here's the first example. We have triangle ABC, and they've told us that ED is perpendicular to AC. They want us to prove that triangle ABC is similar to triangle ADE. Yes, Rekomodetswe, go for it. Oh, sorry, am I still looking? Am I looking? Sorry, I thought maybe you put your hand up again. Sorry. Okay. Sorry, I misunderstood. All right. So this is what I was talking about earlier when I said they are exactly Melakutle. Good. Okay, 100%. When they give you the triangles are similar, they are telling you angle A, look at the order matrix. They're telling you, where's my pen? They're telling you that angle A and angle A, just like Melekutles told us, are equal to one another. They are corresponding angles. They are telling you, matrix, that angle B and angle D are equal to one another, right? And they are also telling you that angle C and angle E are equal to each other, right? But we only have to prove two of the three. The third remaining angles will always be equal to one another because of angle sum and triangle, or the interior angles of a triangle. So now, lovely, you've started us off beautifully at Melekuthle. We have to set this out formally. So we have to say in triangle ABC. Good, Spatle. Nice. Well done. And triangle ADE. We will say A is, so this is number 1, A is common. Okay. Then number 2, angle B equals angle D. Excellent. Both equal 90. Okay. And now you can conclude that the remaining angles are equal. So in other words, B equals C. So Karen, B over here is going to be equal to D. Maybe you just didn't look properly. Okay. And then the remaining angles of the triangle. So we've spoken about A. We've spoken about B. So the remaining angles of the triangle are C and E. There we go. There we go, Melakute. Okay, so angle C will be equal to angle E. And then again, if you want to say remaining angles of triangle or third angle of triangle, I always say angle sum and triangle. Okay, so we have done it. We have proved that these triangles are equiangular. By proving, yeah, well, we've done it by proving that they're equiangular. All right, so therefore triangle ABC is similar to triangle ADE, angle, angle, angle. Okay, so it has to be set out like that when you are proving similarity. Okay, everybody happy? Thumbs up, how are you feeling? Making sense? Good to go? Yes, Asipe.
That makes sense, but I want to say that so let's say the reason is obvious, but then they don't see it as the linear and then the right angle sum of a triangle. Or they mark me wrong. Like I don't know.
Asipe, unfortunately, when you're talking, I'm hearing like little bits and pieces of what you're saying. I'm not hearing everything. Just ask me that question again, please, Asipe.
Can you hear me nicely now, ma'am?
Yes, that's better. Yes.
Okay, so I'm saying, ma'am, we are given another type of triangle where the dead angle, it's obvious, like the reason it's obvious. And I write as the letter, I write angle sum of a triangle. Like, will they mark me wrong when like we can see the reason? Let's say maybe it's co-interior angles. It's just an example. Like it's obvious, and then I write angle sum of a triangle. Will they like mark me wrong or?
If you have proved the first two correctly, then they won't mark you wrong for the third one. No. All right, but you can't use angle sum and triangle as your first or your second reason.
Okay, ma'am.
Okay, you can only use it as your third reason. All right, so you've got to prove the other two. And the other two can be anything, Asipe, anything from grade 8 through to grade 11. So any angles that you can think that could be equal. It could be tan chord theorem. It could be angles in the same segment. It could be vertically opposite angles. What other angles are equal? Exterior angle of cyclic quad. It could be angles opposite equal sides. Any one of those. All right, so any reason where angles are equal, they could bring that in. So essentially, really what they're testing you in matric is this accumulation of knowledge and understanding all the way from grade 8. It's hectic. And that's why it's learning. You've got to learn which angles are equal to one another so that you know what to look out for. All right, so let's have a look at the second example, unless there are any more questions or anything anybody wants to ask. All right, so here, example 2, they give us a parallelogram and they tell us that PQRS is a palm and that PA is perpendicular to SR and that PB is perpendicular to RQ. All right, so the first thing that they ask us to do is they want us to prove the triangle PAS is similar to triangle PQB. So this is something that should be easy for you. They're actually telling you which angles are equal. They're telling you P is common. They're telling you, mind you, it might not be common in this case. Hang on a second, let's be careful. I shouldn't say that. Angle A, they're telling you it equals angle Q, and they're telling you that angle S equals angle B. All right, but we can't just assume, like with the previous one, that P is common. Why not? Why can't I write P as common?
Because we were given a parallelogram, ma'am, not a single triangle that is further divided.
Sure, but this angle P over here, exactly, P's been divided. So this angle P over here that's in triangle PAS, all right, is a different angle to this angle over here. Okay, so it's not two different triangles. That's right, perfect. Okay, so it's not like this one where angle A was the same angle inside both triangles. All right, so here the yellow P is is different to the pink P. Okay, so now who wants to tell us the very first reason here? So let me just write down in triangle PAS and triangle PQB. What are you going to say, matrix? All right, so Rechumeditswe says angle A equals angle B, both equal 90. Thank you, Rechumeditswe. Thank you, Chad. That is perfect. Okay, so number one, angle A equals angle B, both equal 90. I mean, that was obviously given to us. Good, well done. Nice, good, Isaiah, 100%. All right, so that's A and B done. Who would like to offer up another one? What do you think, guys? Okay, remember, they told you, there we go, P equals O, not co-interior angles, Melekuhle. Very good that P equals O. The P equals O. Hang on, no, I'm talking nonsense, Melekuhle. No, yeah. Chad, is that a Q? Oh, yes, this is a Q, isn't it, Chad? So this is a Q here, guys. Okay, you're quite right. Okay, Chad, it's perfect. Okay, angle S equals angle Q. Why? Why, matrix? Why does angle S equal angle Q? Opposite angles of a parallelogram. Exactly. Okay, so now here we are going back to grade 10. All right, so angle S equals angle Q. Opposite angles of a parallelogram, palm, are equal. Okay, so can you see for our first two reasons, we're not allowed to say sum of angles in triangle. All right, it's got to be something else. And now we are allowed to say that angle SPA is equal to angle QPB. Sorry, I'm putting the hat onto the wrong one. And here, remaining angles of triangle or angle sum in triangle or interior angles of triangle sum up to 180 degrees. And now I can conclude. Triangle, PAS, similar to triangle, PQB. Don't forget, angle, angle, angle. Okay, matrix, everybody happy with that? That's quite easy. Okay, now let's go on. Now they want us to prove a proportion based on our similarity. Okay, so now they're asking us, now that we've proved that triangles are similar, they're asking us to write a statement about the corresponding sides that are in proportion. Okay, so remember, this is the first two over the first two equals the second two over the second two equals first and last over first and last. So based on our statement over here, okay, so on this one here where I've got the green star, we could then say PA, I'll do the first one, okay? So PA over PQ. All right, I want one of you to do the second one. Someone tell me what to write here. Good, Silindile, AS over QB. Good. Well done. Yes, Isaiah, same answer. Excellent. Very nice. All right, now somebody else do the third one. Equals?
PS over PB.
PS over?
PB.
PB. Okay. Good. Well done. Now I have to write a reason here. Corresponding sides in proportion. Okay, so that is true because the corresponding sides are in proportion. And now what I like to do, Matrix, is I go back and I get a different color and I say to myself, I need PS. Okay, well, there's PS. And I need PQ. There's PQ. And I need PA. There's PA. I need, let's get a different color, PB. PB. There's PB. Okay, so I've got everything that I need. All right, so now I can write down, therefore, mind you, let's just make that a little bit darker because it might be hard to see, PA over PQ is equal to PS over PB. Now, Rachel Meditswe, I think you put your hand up again. I'm almost finished, but I'm going to give you an opportunity to ask me what it was that you wanted to say. What did you want to ask, Rachel Meditswe?
Ma'am, I wanted to ask, instead of writing the reason corresponding sides in proportion, can you write the answer of the previous question?
No, you mean angle, angle, angle?
Yes, ma'am.
No, you can't do that. You can't do that. So angle, angle, angle is for proving that these triangles were equiangular. For this, now we're talking about the sides, so you have to say corresponding sides in proportion. In fact, in the days gone by, they used to be really, really fussy about this, and they used to make you write corresponding sides of similar triangles in proportion. Now they just accept corresponding sides in proportion. Okay, so yeah, but you do have to write that, otherwise you won't get the reason. All right, so now the last thing that we need to do is just fiddle with this a little bit, because we can see that we've got PA over PQ is equal to PS over PB, and it will be exactly the same thing as if we now conclude, therefore, PA over PB is equal to PS over PQ. That's one of the manipulations that we're allowed to make. All right, so in other words, if we look at it like this, if we've got in blue, if we've got 1 over 2 is equal to 3 over 6. What have we done? Why does that not work? PA over PB equals PS over PQ. No, that's it. Okay. All right. Done. Okay. And now the last thing that they want us to do is they want us to conclude that AS times RS is equal to BQ times RQ, right? So now this is a little bit more difficult. In this particular question, they are asking us to kind of work backwards and decide which sides or which proportions we're actually going to work with. All right, so now we've got AS and RS. So AS is this side over here. AS is this side over here. RS is the whole side. All right, then we've got BQ and RQ. So BQ is this one over RQ is the whole side like that. All right, so this is a little bit more challenging. Any ideas from any of you as to how we would actually answer this question? All right. Not a clue. All right, that's fine. I just thought I'd give you an opportunity to maybe say something. So you've said RS. Yes.
Ma'am, do you like first write proportions, like something over something, and then at the end you kind of like tip and times?
Exactly, quite right. So we've got to write some proportions, and there's got to be some things that are going to be the same. Now remember, we were talking about a parallelogram. Okay, so what do you know about parallelograms? That the opposite sides are equal to one another. So here, side PQ equals side SR. Side PQ, we'll just put that over here. Side PQ equals SR, okay, because they're opposite sides of a palm. And similarly, let's just go back and look at the picture. Side PS would be equal to side QR. So PS equals QR. PS equals QR. Also because they are opposite sides of a palm. All right, so let's go and have a look at what they've given us. All right, so here we see QR. So there's QR. Here's QR. We see BQ. Okay, fine, fair enough. The other thing that we see is SR or RS. And that is the same as this one over here. So in order for AS times RS equals BQ over RQ to be equal to one another, the proportion that it had to come from had to be something like this. So in my rough working over here, I'm going to write that, okay? So AS over something had to be equal to something over RS or SR. Okay, so here, let's put this in a different color to BQ over RQ or QR. All right, so when we cross multiply, can you see when I multiply the two yellow ones together, I get what's on the left-hand side. When I multiply the blue ones together, I get what's on the right-hand side, okay? But now I need to replace QR. Remember, QR over here and QR over there is the same, okay? And SR over here and SR over there are the same. Okay, so in other words, this QR here is the same as PS, and this SR over here is the same as PQ. Now, let's just go back and have a look at our original statement, okay? Do we have something about AS? Yes, we do. So our AS is here, and we've got an AS here, okay? BQ, there's BQ. PS was over here, all right? And PQ was over there. What do we need to remember though? PS is the same as QR. And PS is the same as QR. All right, so let's just write this down. So we've got PS over PQ. Okay, which is this over this, PS over PQ is going to be equal to AS, okay, which is this over here, over BQ, all right, because corresponding sides are in proportion. So that means that if I now cross multiply, I'm going to end up with PS times BQ is equal to, cross multiplying again, AS times PQ. And now I can go and substitute. All right, so PS was the same as QR. So QR times BQ. And I know that AS, I'm going to keep. And AS was the same as, was it RS? SR, yeah. There we go. All right, so a little bit more difficult, but that's how we would do that question. So in other words, we're still working from our same proportion, only now what we need to do is we need to substitute sides that are equal to one another. Okay, so working from our proportion that PS over PQ is the same as AS over BQ, then we can say PS times BQ equals AS times PQ, and then substitute in those things that they're equal to. Okay, how's everybody feeling? A little bit more difficult. How do you feel, guys? Can we do another example? Okay, I am reading. Let's have a look. Did not understand. Okay, let's try this one over here, right? We're going to have a look at number 3. Okay, Luyanda's got an upside down smiley face. Okay, so let's have a look at number 3 and see if we can do this again. Okay, so in the diagram, EF is parallel to CGD, and they've told us that BEC is parallel to FG. Okay, so we've got 2 different triangles, 2 different pairs of parallel lines. But the first thing that they want us to do is to prove that triangle BEF is parallel to triangle FGD. Okay, so let's get that out the way, and then we can talk about what's going on in the next one. Right. So, because we've got to do the similarity first, right? Because everything comes from that. So in triangle BEF and triangle FGD, let's have a look at what we can say. What things are equal to one another? So you've got parallel lines. Which angles will be equal? E1 equals G2, indeed. Why does E1 equal G2, Ayomide? Okay, so E1 equals C because they are corresponding angles. And that's because EF is parallel to CD. All right. Now, angle C is equal to angle G2. Okay. Also because they are corresponding angles. That's because CB is parallel to GF. Okay, so that means that E1 has to be equal to G2. Cool beans. So we've got that much. So they've told us, we know that angle E, see we've proved it, angle E and angle G are equal. They're telling us that angle F, so that would be this angle over here, angle F and angle D would be equal to one another. It's really, really hard to see, but can you see that angle F1 and angle D are corresponding angles? Can you see the upside down F lying on its back? So I'm going to do it in bright blue over here. So there is the one parallel line. There is the transversal. And there's the other parallel line. Can you see it now? These angles over here. Oh, someone said alternate angles. Hang on a second. Let's just have a look at what you were saying over here. So Melekuhle said, no, Luyanda said B is equal to F3. Okay, but there's no reason as to why, Luyanda. Melekuhle says F2 equals G2. Fair enough, Melekuhle, but F2 is not inside the triangles that we're trying to prove are similar. Remember, we're trying to prove BEF similar to FGD. So we can only work inside those triangles. F2 is not inside. All right, so I hope everybody can see that now that I've pointed it out. Angle F1 is equal to angle D, also because they are corresponding angles, and that is because EF is parallel to CD. Okay, and now you can make your conclusion, Luyanda. All right, so in point number 3 now, we can conclude that angle B is equal to angle F3, and now I can use angle sum in triangle. Okay, so therefore triangle BEF is similar to triangle FGD, reason, angle, angle, angle. Okay, everybody happy with that? That's the easy bit. So now in the tricks, when they ask you to prove good stuff. Okay, so hopefully this one is going to make a little bit more sense, and then we can talk about the second one after this as well. All right, so now, if they ask us to prove that DG over FG, so DG over FG is equal to EF over BE, most of the time, 99.9% of the time, when they ask us to prove a proportion after we've proved similarity, it comes from showing that the corresponding sides are in proportion to one another, right? So what you would do in part B is write the corresponding sides that are in proportion. Okay, so this is first 2 over first 2, second 2 over second 2, first and last over first and last. All right, so again, like last time, I'll do the first one for you. All right, so I'm going to write that BE over FG is equal to, and then someone tell me the next bit. BE over FG is equal to?
EF over GD.
EF over GD, I agree. Which is equal to?
EF over FD.
BF over FD. Well done, Saki. That's perfect. Okay, and then I must write corresponding sides in proportion. Okay, and then go back and again with your colors. All right, so we want DG, we want DG. We want FG. There's FG over there. We want EF. There's EF. We want BE. What color can we use? Bright blue. BE. And there's BE. Okay, so now we know which proportion to use. So we're going to conclude, therefore, BE over FG equals EF over GD. But what do we have here? We have BE over there and GD. Okay, so what do we need to do here? We need to do one last manipulation. We need to interchange GD and BE. So in other words, what I'm doing is I'm interchanging these two. So I'm writing that DG or DG, so I'm putting this one at the top here over FG is equal to, and then I'm keeping EF in the top over BE because I interchanged them. Okay, so BE and GD changed places, all right? And I'm allowed to do that. I'm allowed to do that because if I write, for example, so this goes back to the proportions that we were talking about in the beginning. If I write 1/2 equals 3/6, I'm allowed to interchange. So in other words, if I write 6/2, it's going to be the same as 3/1. Okay, so the 6 and the 1 can change, and that's exactly what I've done here. How does everybody feel about that? Does that make sense? Good, much better. All right, I'm so glad. Okay, maybe the first example wasn't a great one. This one was better. I'll remember that for next time. Good, I'm glad. Okay, yeah, it is a lot of brain work, Hamid, quite right. Well done, sweetie. Yes, thank you, Asipe. Good stuff, guys. All right, are we ready to do the next one? So now here, have a look at this, right? Now here we start to see circles for the first time. All right, and this is what we've got to expect, matrix, because they are putting our grade 11 work and our matric work together. So if we read what it says to us in question 4, it says that PB is a tangent to circle ABC. So the minute we see the word tangent, we have to go back to grade 11 and we have to think of all of those reasons that came together with tangents. So radius perpendicular to tangent, or tan chord theorem, or tangents from the same point, etc., etc. Okay. And then they've also told us that PA is parallel to BC. They want us to prove that triangle PAB is similar to triangle ABC. So of course, this is the easy bit. They've told us which triangles to prove are similar to one another. Okay, so I'm going to try and do less of this, and I'm going to try and get you guys to do a little bit more. All right, so I'm going to write in triangle. So this is obviously part A. So in triangle PAB and triangle ABC. All right, so who can tell me the first thing? Triangle PAB is this one, and triangle ABC is the other one. Can someone tell me if there are angles that are equal?
Angle A1 and angle B2, ma'am.
Lovely. And the reason?
Alternating angles.
That's it. So alternate angles. And again, I've got to remember, oops, he's supposed to be there. That's just supposed to be an L. Alternate angles, and that is because PA is parallel to BC. Good. Okay, so now here we can see we've used the A over there and the B over there. Both of them are in second position. All right, good job. Okay, next one. Tan chord, Luyanda says. Okay, so tan chord theorem. The angle between the tangent and the chord is equal to the angle in the alternate segment. So angle B1 is the angle between the tangent and the chord, and that's equal to the angle in the alternate segment. Quite right. So that would be equal to angle C. Good, Luyanda. So B1 equals C, and that would be tan chord theorem. So remember, I'm not allowed to say remaining angles of a triangle or angle sum and triangle. It's my first two reasons. Okay, so now we've got the B over here and we've got the C over there. So now we know the conclusion we can make. Angle P in this triangle over here has to be equal to which angle in the other triangle? It has to be equal to angle A2. Does everybody see that? Okay, and then we would say angle sum, triangle, therefore triangle PAB is similar to triangle ABC, angle, angle, angle. Okay, So that's the easy bit, all right? Everything else comes from there. All right, now let's go and have a look at what they want us to do for part B. So in part B, they want us to show that PA is to AB is the same as AB is to BC. So where do we think that comes from? What should I write? Okay, Sparkle, where did I lose you? Can you please explain for number 3? How are they equal? Okay, so they are the remaining angles of the triangle, Sparkle. Okay, can you see? I've tried to do it in different colors here. We've got the pink angles that are equal. So in other words, this angle over here, B2 and A1 are equal because they are alternate. Then we've got the green angles. This is this one over here, B1 and C. They're equal because of tan chord theorem. So the remaining angles in both triangles, P is the remaining angle in triangle APB, and angle A2, Sparkle, is the remaining angle in triangle ABC. Okay, so that's why P is equal to A2. They are the remaining angles of the triangle. Does that make sense, Sparkle? Cool, it's a pleasure. Good job, Matrix. All right, so now how are we going to answer question B? It's really actually not a difficult question. They want us to write something about the corresponding sides and proportions. So the minute that you've proved similarity, the next step usually always is to write the corresponding sides and proportions. So I'm not going to do that. I'm going to get you guys to tell me what to write. Okay, so now corresponding sides and proportion. So now first 2 over first 2, second 2 over second 2, first and last over first and last, okay? So what should I write?
PA over AB.
PA over AB is equal to, good.
AB over BC.
Good, well done. Is equal to?
PB over AC.
PB over AC. Good job. That's it. Quite right. Reason? Corresponding sides?
Corresponding sides in proportion.
Exactly. Corresponding sides in proportion. Good. Well done, Silindile. Okay, now they're only asking for PA and AB. So they're asking about the first fraction. That's this over here. And then they're asking about the second fraction. So that's that one over there. So that's this bit. Right. So what we are saying is that the relationship between the numerator and the denominator is the same as the relationship between the numerator and the denominator. So again, if you've got 1 over 2 equals 3 over 6, we are saying that 1 is to 2 is the same as 3 is to 6. That's the equivalent of what we're saying. Does that make sense to everybody? That's where it comes from. Okay, so how the numerator is related to the denominator in the one is the same as the relationship between the numerator and the denominator in the other one. Is everybody okay? Thumbs up, thumbs down, how are you feeling? Sake, good. Ayomide, good. Good, Silindile. I'm glad. Samara, Rekomoditswe, lovely. Thank you, guys. Benedict, nice. Well done. All right, so now let's finish this baby off. Okay, so the last thing that they want us to do is AP over BP is equal to AB over AC. All right, so again, I mean, I've gone and written in color all over this, but let's go and see if we can find some. Let's just get rid of that, and let's just get rid of that, and that, and just make it a little bit easier to read. Okay, so let's go up. Okay. Now, this AP over BP equals AB over AC. Maybe we've already got it. Maybe what we need to do is just go back and look at our proportion statement and just see if any of the things that we want are already there. So there's, hey, what's it doing? So there is our AP. Here's our AP. Okay. And here's our BP. And our BP is over there. Then we want AB, which is that one over there. And let's do AC, which is this one over here. All right, so we've already got it. We don't have to reprove it. Right, we can work from our proportion statement, corresponding sides in proportion from question C. So let's write that down exactly as it is. So we've got PA over AB equals PB over AC, proved above. And now they want us to manipulate it in some way. So what do they want us to do? Any ideas? I'm going to see if you guys can figure this one out. What do they want us to do? Matrix. No need to construct triangles. We've got everything we need, Melokule. We are one step away from the answer. All we need to do is interchange some stuff. We don't have to construct any triangles. We've got everything that we need in our PA over AB equals PB over AC. Can anybody see it? Yeah.
Interchange BP and AB.
There we go. Exactly. So interchange AB and PB. Right. And again, exactly. Interchange denominator with numerator. Exactly. So across like that or across like that. Perfect. And that's it. And then we're done. Okay. So let's just move it like this. Okay. So now interchanging them. We've now got, so we'll write AP or PA as AP. We're going to interchange AB and PB, so those two. So I'm going to put PB down at the bottom, and I'm going to put AB at the top, and AC underneath. Okay, and that's it. I've done everything. Okay, so how are you feeling? Making a bit more sense? Are you feeling a little bit more confident in this section? Okay, good. I'm so glad. Cool, Benedict. Cool, Silindile. Thank you, Ayamida. That's great. Spatle, yes. Good. Good, good, good. That's what we like to hear. All right, so let's move on and let's talk about when things are a little bit more difficult. Okay, now I don't know how far we're going to get because we're already sitting at 6:30, but let's just see how it goes, right? So now, sometimes what happens is that we are asked to prove a proportion and we have no idea where it comes from because they haven't asked us to prove triangles are similar first. So for example, let me just show you what I mean, like here. So ABCD is a cyclic quad, ABDC produced to meet at E, prove that AE over CE equals AD over BC. We've been asked to prove a proportion, but we haven't been asked to prove triangles are similar. So what do we do in a situation like this? Does anybody know? Or is this something that we would really struggle with? So you can pop it onto the chat. There we go, Melakuhle. Okay, so we're going to have to identify the triangles that we are going to prove are similar to one another. So this is really important for you, okay? You cannot write down AE over CE equals AD over BC. You cannot write that on the page, right? That's what you're trying to prove. So that cannot be your opening statement. All right. And they are very, very particular about that. Your opening statement has to be in triangle, whatever, 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 and triangle, whatever, whatever, whatever. So if they don't tell you which triangles are you need to prove are similar, and they ask you to prove a proportion, you first need to establish the triangles that you need to prove are similar to one another. And there are two ways in which we can do that, matrix, okay? So either, and I'm going to use number one as an example. So either we go left and right. So in other words, left and right means like this, okay? So across this way. And we ask ourselves, is AED a triangle? AED. So yes, AED is a triangle, so that worked. Now that means if we go left and right over here, is BCE, whoopsie, BCE a triangle? BCE, yes. So left and right worked as well. Okay, so either we can go left and right for both of them, or we can go around the outside. Okay, so this is what worked in this case. So just going back here. Okay, so either you can move horizontally over the proportion, so which is what I've just done in question number one. So ABD, so is triangle ABD a triangle? If it is, then that's fine. Is triangle DAT a triangle? Then it's fine. Then we can work with those. If that doesn't work, then you move vertically over the proportion. So now you're saying, is ABD a triangle? Is BDT a triangle? And then you try it vertically. So either you try it horizontally. If that doesn't work, then you try it vertically. Is this something that you are familiar with? You've heard this before. Do you know what I'm talking about? Yes, okay. Okay, so Karobo says yes, but I'm not really hearing anything from anybody else. That's fine, it doesn't matter. First time that you're hearing this. Okay, I am Ede. But you understand it. Okay, Chad. All right, so they've asked us to prove a proportion without giving us the similar triangles. So we went across vertically and we asked, do those three letters make a triangle? And we asked the same thing at the bottom, but going across horizontally, do those three letters make a triangle? If the answer is yes to both, then you know which triangles to work in. So the first thing that you are going to write on the page, okay, the first thing that you are allowed to write is, let's not write in black, let's write in color. In triangle, AED, and triangle, CEB or BCE, it really doesn't matter, and triangle, BCE. Okay, now, we don't know if our order is correct. We don't know if A and B are corresponding angles or if E and C are corresponding angles. So let's go and have a look at the picture, all right? So we're talking about AED, which is the big one, AED, and we're talking about BCE, which is the little one. Okay, well, what's the first thing that we can say about these two triangles? What's common?
Angle E.
Exactly. Okay, so angle E is common. Good job. Okay, there we go. Okay, so now we've got one angle. Now we need one more angle and we can prove it. Remember they told us that ADCB is cyclic. So what does that mean for us? If ABCD is cyclic, grade 11. Which angle would D be equal to?
The opposite exterior angle.
The opposite exterior angle. So no, not B1, Chad, not B1 cylindile. It would be B2, the opposite exterior angle. Okay, yes, Rekomeditswe, that's right. Okay, so D would be equal to B2, exterior angle of a cyclic quad. And similarly, angle A would be equal to angle C2. Okay, all right. So here is your cyclic quad, interior angle equal to opposite or exterior angle. Okay. So now you don't have to use remaining angles of a triangle, but you can if you want to. So let's start off by saying D, I hope you can see this, angle D is equal to angle B2. Reason, exterior angle of cyclic quad. And then for number 3, I can conclude that angle A has to be equal to angle C2. And if I say remaining angles of a triangle or angle sum and triangle, or if I say exterior angle of cyclic quad, is it going to matter? Can I do that? Am I allowed to do that? What do you think? Yes, quite right. Absolutely. So whether there's a reason or a specific reason for it, like exterior angle of cyclic quad, or whether it's remaining angles of triangle, both are correct in this case. All right, so it does not matter in this particular question. Okay, so now we have proved that, let's just finish this off. We have proved, therefore, triangle AED. Now I've got to be careful, okay? Now that I've proved that they are similar, I've got to get the order right, okay? So angle A in AED, in the big triangle, went with angle C in the little triangle. Angle E in the big triangle went with angle E in the little triangle. All right, and angle D in the big triangle went with angle B in the little triangle. So in this line, I must get the order right. Angle, angle, angle. Does that make sense to everybody? Okay, so in this point over here, the order has to be correct. And I'm going to write that for you over here. Why do you think it's so important that the order is correct, Matrix? Why do you think it's so important? What are we going to do based on these triangles? What are we going to do now? Exactly. We're going to write our proportion statement, aren't we? So if we don't have the correct order, first two, second two, first and last, we're going to get all jumbled up and we're going to make proportions that aren't true. Okay. And we're going to get horribly confused and very upset, and nothing is going to make any sense to us. So when you are first setting out in which triangles you are working, the order is not important. So here up at the top, okay, there, doesn't matter. But after you have proved angle, 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 then when you are writing over here where I've put the red star, the order needs to be correct. Okay, so that your corresponding sides in proportion is also correct. So now I'm not going to tell you what to say. I want you guys to tell me first and last, first two, second two, first and last. What should I write here?
Over CE.
So AE over CE, good as CP, keep going.
Is equals to ED.
Yes.
Over EB.
Good girl. Okay, keep going.
Which is equals to AD.
Yes.
Over CB.
Lovely, beautiful. Reason?
Sides in proportion.
That's it, corresponding sides in proportion.
Corresponding sides in proportion. Okay.
That's wonderful. Well done. Okay, very nice. And now the last thing that we want to do, Matrix, is we want to go back and just have a look, all right? What were they asking us to work with? AE and CE, AE and CE. So that's these two over here. Let's just get... That's these two, AE and CE. They gave us that. And going back up again, AD and BC. AD and BC. And can you see there, Matrix? AD and BC are over here. All right. So very, very important that you get the order correct in your line with the red star. Okay, so now we're allowed to conclude. Therefore, AE over CE equals AD over CB. All right. How do you feel? Does that make sense? Are there any questions? You sure, Sake? Okay. All right, Benedict. Lovely. Thanks, Chad. Good. Okay, Swalithli. Thanks, Sake. No problem. Okay, so we've got 15 minutes. Let's try and smash this next question in 15 minutes and see what we can do. Okay, so we've got AD is a diameter of circle ABCD. AE is perpendicular to BC. So if AE is perpendicular to BC, AE is perpendicular to BC, it means that angle E1 and angle E2 must both be 90, right? Then they've told us that AB, AD, AC, and DC are all chords. Fine, fair enough. Prove that. AB over BE equals AD over DC. So same story as before. You are not allowed to write this proportion as the first thing that you put on the page. When they don't tell you which triangles they want you to work in, which are similar, they want you to first establish that, prove that they're similar, and then do the corresponding sides in proportion in order to get your answer. Okay, so now, what's the rule here? What are we going to do? Okay, left and right or up and down? Okay, so first thing, we are going to ask ourselves, is ABD a triangle? ABD. What do you see, guys? Is ABD a triangle? Nope. No. Okay. So left and right didn't work. Okay. So now we've got to go up and down. So now we want to go this way. So now we say, is ABE a triangle? ABE. And as it turns out, it is. So there is triangle ABE. And I'm going to try and draw it as neatly as I can. There's triangle ABE. Yes, so that worked. So now I've got to go around the outside over here as well. Is ADC a triangle, Matrix? ADC. ADC. Yes, it's a triangle. Okay, can everybody see that? I'm going to highlight it in yellow. ADC. There we go. All right, so now we have figured out which triangles to work in. So we can get rid of all of this. All right, and the first thing that we put on the page is the triangles we are going to work in. All right, so in triangle ABE and triangle ADC. So AD is the diameter of the circle. And they've given us chords there. So telling us that AD is the diameter of the circle, they're dropping like a massive hint here. All right, they're telling you there are angles that are equal. So which angles are equal? Because AD, which angles in the triangles we're trying to prove are similar, are equal because AD is a diameter. What do we know about the diameter, guys?
E1 and E2.
Yes, so E1 and E2 are equal to one another, but is E2 an angle in one of the triangles in which we're trying to work?
No, it's not.
No, it's not. Unfortunately, it's not. Okay, so we can't work with angle E2 because it's not inside one of the triangles. So in triangle ABE, we've got triangle A1, B, and E1. In triangle ADC, we've got A2, D, and then the whole of C, so C1 and C2. So what does Nicole ask? Sayuri says C equals 90 angle in a semicircle. Angle suspended from diameter are equal to 90 degrees. Both of you are 100% correct. Okay, so the diameter subtends a right angle at the circle. So good job. Okay, angles C1 and C2. So I can call this whole angle here ACD. ACD is equal to angle E1 in the red triangle. In fact, hang on. What I should rather do is this. I should rather say ACD equals 90 degrees. Angle in a semicircle. I hate it when the pen does this. Hang on. Oh man, come now. Sorry, Matrix. Angle in a semicircle. Then we know, now unfortunately I moved the diagram. Let's just move it back. Okay. And we know that angle E1 is also equal to 90 because we were given that AE is perpendicular to BC. So that means that angle ACD is equal to angle E1. Okay, so that's our first one. Okay, so this angle over here, E1, is equal to this angle over here. All right, what else? What else have we got? Okay, so this means knowing your grade 11 work really well, okay? If you can, I don't know if it's possible for you to do this, but if you put your fingers at A and C, AC is a chord. AC subtends D at the circle, go back to AC, AC subtends B at the circle. So B and D are angles in the same segment. Can you see that? Angle B, yes. Okay, angle B equals angle D. They are angles in the same segment. Okay, so that's going back to grade 11. All right. And now that we've got our two angles, now that we've got, let's just color them in. So now that we've got that angle B over here and angle D over there are equal, what are the remaining angles? So it's going to be angle A1 has to be equal to angle A2. Angles sum in triangle, okay, or remaining angles of triangle. Everybody happy? Okay, so now order correct. We have to get the order correct. So now I'm going to get you guys to tell me what to write. So therefore, triangle. And if we want to keep ABE like it is, that's fine. Okay, so what letter do I need to write next?
D.
Unfortunately not. Not D.
A.
Angle A,
A.
it's A, exactly.
A.
Okay, so angle, so in triangle ABE, in the red triangle, A1 goes with angle A2 in the yellow triangle. Good. Okay, so A goes with A in this case, even though it's not common. All right, it's because of remaining angles of a triangle. What does B go with?
D.
Yes,
D.
Chad. It goes with D. Good, Benedict. Okay, it goes with D. Nice, guys. And angle E goes with angle?
C.
C, good. Okay, so angle E1 went with angle C1 and C2. Okay, or ACD as we called it. Okay, very important that we get the order correct so that our proportion statement is correct. So therefore, oh, sorry, first of all, angle, 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 and now, oh, we're running out of time. Time is always, we're gonna have to do questions like that next week. See if we can. Okay, so now we want to make our proportion statement. Okay, so someone tell me what to write. We're making our proportion statement.
AB over AD.
AB over AD. Yes, keep going. Equals.
Equals to AE over AC.
AE over AC. Good. Keep going.
Equals to BE over DC.
Good. Reason? Corresponding
side
in
proportion.
That's it, Sparkler. Okay, corresponding sides in proportion. Okay, now that we get here, we go back and we go and have a look. What did they want? A, B, and BE. Okay, so let's just see if we can get them all onto the same page now. Okay, so again, we're going to use our different colors matrix. All right, let's go back and have a look. Okay, so there's an AB up here, and there's an AB over there. There's a BE over here, and there's a BE over there. There's an AD over here, and there's an AD over there. And there's a DC over here, and there's a DC over there. So we've got it. Okay, all we need to do is write it down. So again, I'm just going to move it up a little bit. So I'm going to write down, therefore. So AB over AD equals BE over DC. But. Okay. AB over BE equals AD over DC. What do I need to do here, guys? Swap, exactly. I need to interchange. All right, so they want AB at the top, but they want it over BE. So what two things am I going to swap, Chad? What am I swapping? Exactly. All right, so those two. All right, so therefore, AB over BE equals AD over DC. All right. How do you feel? You feeling good? Is it making sense? Everybody happy? Cool, Amy. Good, Saki. I love it. Oh, nice, Chad. Thanks for the smiley face. That's lekker. Nice. Feeling good. Good, Sayuri. Happy. Thank you, Spotless. Samara, you're also happy. Good. Brain is hanging on but making sense. Thank you, ma'am. It's a pleasure, Hamid. Thanks, Benedict. Okay, Karava, that's lovely. Sure, our time goes by so fast, doesn't it? Here we are, 2 hours later. We could sit here all night. Not that I'm sure you've got better things to do than that. And also Hamid's writing his first paper tomorrow. So, yeah. Okay, well, all the very best if you are writing tomorrow. I hope it goes well. Get a good night's sleep and eat a decent breakfast before you go in, and stay calm and read the questions. And even if it's not maths, remember that everybody here at Watobe is rooting for you and wishing you all of the very best and just wants you to do really well. Okay, so good luck, guys. I hope everything goes well for you. And I'm going to hand you back over to Michaela.
Actually, Coco, because Michaela's
Coco is back. Okay, cool. Hello, Coco.
Hi, Lee. How are you?
I'm fine, and you?
I'm well, thank you. She had to rush off because she was doing another grade, 6 p.m. class for another grade, so I'm here.
Cool. All right. So Chad and Hamid are just busy wishing one another good luck. So that's really cool.
I am so happy. I'm so glad to see that. I hope you guys wish each other luck all the time.
Well done, Janelle. No problem.
Yeah, and guys, please keep us informed on what you guys are doing and how you guys are doing with your exams. We'd love to know how you guys are going. Our mentors are here to speak to you guys if you're feeling a bit overwhelmed with all your exams. So don't be afraid to reach out, to also encourage each other in the chat as well. Okay, I'm gonna get into the homework. So I'm just gonna share my screen quickly. Let me just make sure I'm on the right page here before I start sharing things. My goodness. All right, here we are. Okay, so we are officially into 3 lessons. This is lesson 3 of the 4 lessons on geometry, on Euclidean. I don't know if it's Euclidean geometry.
It is Euclidean geometry. Yeah,
right,
it is.
There we go.
It is, yeah.
Okay. Yeah, on Euclidean geometry, we're going to have our last lesson on this subject on Wednesday. It doesn't mean that the lessons stop here. We'll be having another one on Saturday and a couple more coming until you guys write your exams. I think the one on I think the one on Saturday is the last one, hey, because you guys are writing maths right at the beginning of November.
They are.
Yeah, so
they are. They are. So yeah, nearly there.
Yeah. Yes. Okay, awesome. All right. The homework that we're going to be looking at is geometry. Okay. And we're going to be going to similarity, and we're going to be looking at similar triangles theorem. And you guys can go through that. It will help reinforce some of the stuff that you've done today and hopefully help you guys get ready for the exam that's coming up soon. All right, again, this is our whole week schedule, We are currently on week 3 and we are doing geometry workshop 3. So we've got geometry workshop 4 left, and then the analytical geometry one on Saturday. And then the whole of week 4, which is next week, we are just going to be doing a Q&A. So anything that you guys are unsure of for your exam, bring all of that through. Make sure that Lee and I think Jen and Marlies will also be there to help you guys work through any questions that you still might have right before your exams, just to get you guys ready. All right. Again, if there's anybody you know who would benefit from this, please send them a link to our website so that they can come and check this out with us. Okay, that's it from my side. Thank you guys so much for joining us this evening.
Excuse me.
Good luck to everyone. Yes, Hamad, good luck to everyone. Good luck, say good luck to your fellow matrics. Make sure you guys are encouraging each other, even if it's in the chat. I think we can find a way to send all of these messages to you guys. Oh, I think I have something for our marketing team. You might be able to start an Instagram good luck page for all of you guys so that you guys can send all those messages. So please follow us on Instagram as well, and we'll be able to send all your messages to each other. And you guys can just send each other good vibes so you guys can pass your exams. All right, that's it from us, guys. Thank you so much.
Excuse me, ma'am. How do I find and submit my homework?
So there was a question.
How do I find
Spache, what was that?
How does she find the homework?
So if you log into your app and you click on topics, all the matric subjects should be there. So if you click on topics, you just go down and look for geometry and look for a section called similarity in there. And you should be able to find it. Can I share my screen for just one more second so we can have a look at that again?
So it's on the app, it's on the Watobe app.
Yeah.
Okay, Spache.
So you will be able to find it pretty easy.
Okay,
So if you go in and you click on topics, you'll find this will come up, this page that we're looking at. And if you click into geometry, this kind of page will come up, and you just
got to scroll down a little bit.
Yeah, scroll down a bit and you'll find
scroll down a bit, and
similarity,
then you'll find similarity. Yeah. Sorry, Coco.
No problem.
Sorry.
Okay, is that okay, Spache? Are you good?
Yes, thank you.
Sure, awesome stuff. All right, guys, go have dinner, get some rest, but then keep at it. Okay, all the best of luck to you guys. Bye-bye, everyone.
Bye, everybody. Well done. Thank you.
Bye.
Bye, everyone.